4 properties in trends in physical property. Now the fifth property is color. This property is very important and it depends upon absorption of energy from visible light. And visible light means particular wavelength of visible light. Wavelength of visible light ranging from 400 to 800 nanometer. So here important part is wavelength of visible light. Okay. So compounds of transition element are in colored form in their solution or solid, that doesn't matter. But the color is depends upon two factors. First is incomplete d orbitals. D orbitals means n-1 d orbital, last orbital. And the second is unpaired electrons. Incomplete d orbital means d orbitals there are 5 orbitals. 5 orbital, when each orbital have 2 electrons, then it is complete. And 1 electron, that means incomplete. No electron, that means empty orbital. So we have only the orbital having 1 electron. So that's the incomplete d orbital. And each last orbital contain single electron. They are unpaired electron. They call as a unpaired electron. So these two factors are important for the color of transition element and their compounds. Unpaired electron 0, then compound are in colorless form, while more than 0, then compound are in colored state. So 0 unpaired electron, that means no unpaired electron, and more than 0, that means 1, 2, 3, 4 and so on. They are colored in. In the compound form, the d orbital are splitted. There are 5 d orbital. This splitted into 2 sets. One set having 3 orbitals and one set having 2 orbitals. The 3 orbitals set at lower energy while 2 orbitals set at higher energy. These orbitals lie in between the axes, so they are dxy, dyz, dxz. While higher energy level orbitals lie on the axis, so they are dx square minus y square dz square. Electron first fill lower energy singly, then higher energy level, and after that they get pairing from lower energy to higher energy. This property seen in the next example. For example, TiH2O 6 3+. This is the coordination compound which having +3 ion, +3 charge. So in which H2O is neutral, so they have no charge. That means +3 charge is of titanium. Now see electronic configuration of titanium. That is Ar 3d2 4s2. Now for titanium plus 3 because they have plus 3 charge. So plus 3 charge, that means they already lose their 3 electrons from its ground state electronic configuration. That means the electron configuration are AR. 3 electrons removed. First from 2 electron from 4s, so 4s 0, and 1 electron from 3d. So now remain is 3d 1. So there is only 1 electron present in 3d orbitals. Now this first electron can be placed in lower energy level because of their stability. So first electron present in lower energy, that means 3 orbital set, which are also called as T2G, and 2 orbital set also called as EG. So these are T2G orbitals and these are EG orbital. Now electronic configuration. At ground state is T2G1 because 1 electron present in T2G. So T2G1, but EG0 because they have no electron. So this is condition in ground state. But these compound when absorb a particular wavelength of visible light, absorb particular wavelength of visible light. So particular wavelength, that means they absorb a particular color light. Each wavelength have particular color. So of a particular color visible light they absorb. After that, this electron excited to lower energy to higher energy. Lower energy to higher energy. But after some time, this electron permanently not stable in that higher energy level. So they lose their energy to get original position. Lose their energy, goes to original position. That's emitted light having color which will be absorbed on that compound. So we see the color of compound or transition element, that the emitted color, which is also called as complementary color. That means suppose yellow light, yellow or green light absorb and purple light is emitted light or complementary color. So we cannot observe yellow or green color on that compound, but we only observe the purple color on that compound because this is complementary color or emitted light. We only see the emitted light color, not absorbed light color. But emitted light color is depends upon absorbed light color, so it is called as complementary color because of it is depends upon absorbed light color. The color of transition ions is related to first number of unpaired electron, second DD transition. DD transition means 3 orbital series to 2 orbital series, that means T2G to EG. Here electronic configuration at ground state is T2G1 to EG0, and after that electronic configuration at excited state is first electron is goes to 2 orbital series. That means there are no electron in T2G. So T2G 0, but EG have 1 electron. So EG 1. That means electron configuration at ground state T2G 1 to EG 0. But after that excited state T2G 0 and EG 1. After the relaxation of energy, that means immediate light color, they emit energy. Then electron configuration becomes have ground state. That means T2G1 to EG0. That means these two d orbital shift electron from lower energy to higher energy. Then it is called as DD transition. So the color depends upon paired electrons, DD transition, this DD transition and unpaired electron, which are the two main factors in that. After that, geometry of complex and nature of ligand. These two factors we detail study in coordination compound or coordination chemistry topic. Here only two factor detail study, but these two factor detail study in coordination chemistry. Next chapter, the table of color of 3D transition metal ion, because metal have no color but ion have color. So we observe the chart of metal ion color. So first ion, metal ion, then the electron configuration, then unpaired electron, final color. We divide into two sets. The chart is divided into two sets. First have majority of +3 ion. So we started from scandium. Scandium +3, titanium +3. Also titanium have +4 oxidation state. Then vanadium +3, chromium +3, manganese have +2 and +3 ion. So there are 7 ion in first 5 elements having one side. So now we observe d electron configuration. Scandium +3. Scandium electron configuration is Ar 3d1 4s2. For +3, 3 electron can be removed. 2 electron from 4s and 1 electron from 3d. So there is no electron in 3d. So here electron configuration is d0 because d orbital have no electron. And we already see the color is depends upon dd transition. That means only d orbital. Only depends d orbital. So there is no electron. For titanium +3, titanium oxidation state, titanium electron configuration is 3d2 4s2. For +3, 2 electron from 4s and 1 electron from 3d remove. So there is only 1 electron is present. So this is D1 case. For +4, again 1 more electron can be removed from D1. That means the remaining electron configuration is D0. 2 electron from 4s, 2 electron from 3d. For vanadium, 2 electron from 4s, 1 electron from 3d. So electron configuration becomes helium electron configuration is 3d3 4s2. 2 electron from 4s, 1 electron from 3d, remove. So D2 case. For chromium 3d5 4s1, 1 electron from 4s and 2 electron from 3d, remove. So so there are D3 case. For manganese 3d5 4s2, 2 electron from 4s, remove. Only plus 2, that means 2 electron only remove. 2 electron remove, that means 3d5, so D5 case. And for Mn plus 3, 2 electron from 4s, 1 electron from 3d. So remaining electron configuration is 3d4, that means D4 case. Now we write unpaired electron. So d orbital have 5 orbitals. So each orbital having 1 electron. First electron fills singly. So they are already number of unpaired electron. So it contains 0, 1, 0, 2, 3, 5 and 4. So these are unpaired electron. We already known the compound have 0 unpaired electron, then they are in colorless form. So these two cases have colorless. But Ti plus 3 have 1 electron, and we observe the color in example, that is purple. For D2 case, that means 2 electron, that is green. For 3 electron, it is violet. For 5 electron, that is light pink. And again for 4 electron, which is also violet. So there is no relation between number of electron and color. That's not depend upon number of electron. The observed color is depends upon frequency of light or wavelength of particular light. See, in the second D series. In the first D series, there are 7 ions, and out of which most of ions have plus 3 ion. But in the second D series, most of ions have plus 2 ion. So we see the second set, that is Fe plus 2, Fe plus 3, have extra ion, CO plus 2, UNI plus 2, Cu plus 2, Cu plus 1, which is also extra ion, and the last is Zn plus 2. Now we observe the electrons. So here in Fe, the electron configuration is Ar 3d6 4s2. So for plus 2 ion, only 2 electrons removed from 4s. So d orbital having 6 electrons. So this is d6 case. For plus 3, 1 extra electron can be removed from 3d. So 2 electron from 4s, that means 4s 0, and 1 electron from 3d, that means 3d6 becomes 3d5. So which have d5 case. Now for CO plus 2 cobalt 3d7 4s2. 2 electron from 4s remove, that means d7 case. For nickel, electron configuration 3d8 4s2. So here d8 case. For copper, electron configuration 3d9 3d10 4s1. So here 1 electron from 4s remove, that means 4s 0, and 1 electron from 3d remove, that means 3d9. So here d9 case. For Cu plus 1, electronic configuration 3D 10 4s1. For plus 1 ion, that means only one electron can be removed from 4s. So remaining case is 3D10, so that means D10 case. For last zinc, electron configuration is 3D10 4s2 plus 2 ion. There are 2 electrons removed from 4s, so electron configuration becomes 3D10, that means again D10 case. So from that we cannot understand the color of compound. We understand only on unpaired electron, number of unpaired electron. So we calculate first number of unpaired electron in disruption. So for D6 case, there are 5 d orbital. First, each orbital fill single electron. That means 5 electron can be filled in d orbital. Only 1 electron remain. That will be no option to get half fill. So they have only option to fulfill with another. So first orbit get completely fulfilled, and we cannot study fulfill or empty orbital. We only study half filled orbital. That means incomplete d orbital. So here there are only 4 unpaired electrons are present in D6 case. While for D5, 5 electron get single fill, that means the unpaired electrons are 5. For D7, 6th electron paired, 7th electron paired, now only remain 3 electrons are unpaired. So it contains 3 unpaired electrons. For D8 case, again 1 electron get paired. So only 2 electron remains. So unpaired electron are 2. For D9 case, only 1 unpaired electron present. For D10 case, that means fulfill. So there is no unpaired electron, that means it is 0, and again D10 for 0. So in previous study, the unpaired electron are 0, then it is colorless. So first these 2 cases recorded as colorless in nature. Okay, now remain 5 cases in which first is pale green, 5 electron that is yellow, 3 electron that is pink, 2 electron that is green, 1 electron that is blue. So this is second set of the table of color of 3D transition metal ion.